So when we're saying our degree of two variables is the highest sum of the term's exponents, again, sum means we are going to do what? What operation does sum mean? Add. So we're going to look at all the exponents. We're going to add the exponents up for each individual term, and whatever that highest sum is our degree. So if we look at our checkpoint here, it looks something very similar to what we did on Friday. We're subtracting two polynomials, okay? But now if you notice, on Friday we only had x's in there. Now we have x's and y's, so it's two variables in the polynomial. A lot of it still is going to stay the same. We have subtraction, and there's parentheses around that. We're subtracting that whole polynomial. So therefore, that means we have to distribute that negative sign through. So I'm going to take it and distribute this negative sign through. I do not need parentheses around that first polynomial, so I'm not going to write them. And then I distribute that, so I'd have negative x cubed plus 6x squared y, and then minus y cubed. And just like always, we can only combine like terms. So like terms have to be the exact same variables with the exact same exponents. So we have x cubed and negative x cubed. So what's going to happen to the x cubed and the negative x cubed? They'll cancel out. And then we'll go to the next one. We have x squared y. That's xy squared. Is that the same thing? No. Here we have another x squared y. So those would be like terms in the red. I have a coefficient of 6 and a coefficient of negative 4. So 6 minus 4 is 2, and I have to keep the x squared y with it. Okay, remember, when we're combining like terms, you just add or subtract that coefficient. The variables never change. All right, then we look at the next one. We have xy squared. There's no other xy squared, so I'm just going to write plus 5 xy squared. And then last but not least, we have negative y cubed and negative y cubed. Negative y cubed minus y cubed is negative 2y cubed. Just double check, there's no other like terms within that. So we are finished with that. The only other thing we now want to say is, what is the degree? Since this equation has more than one variable, we have to kind of go through here and see what our degree would be. So we really have an exponent of 1 there. What's 2 plus 1? 3. So that has a 3. This is 1 plus 2. That also has a 3. This happens to be a 3 also. So this is a degree of 3. Now again, it's not often that all terms have a 3. That's kind of rare actually. But you do have to kind of go through and add up all the exponents for each term, and whichever the highest one is now the degree. All right, so here's 2 more examples. Notice we'll have to FOIL the first one. The difference between this and what we did the other day is that we have 2 variables. We have an x and a y now, not just x's. Okay, but the process is going to remain the same. We still want to FOIL. So we have 7x times 3x is 21x squared. 7x times negative y. What would 7x times negative 1y be? Logan, what do you think?
What?
7x times negative y.
Oh, negative 7x.
Yes. And then I do my inner parts. Negative 6y times 3x. Negative 6 times 3 is negative 18, and then xy. And then negative 6y times negative y will be positive 6y squared. Combine any like terms. The middles have like terms. So minus 25xy plus 6y squared. And again, we want to find our degree. And in this case, our degree would be 2 again. We have a 2 here. This is 1 plus 1, which is 2. That's also 2. Again, it doesn't always have to be the same. You're just doing what is the highest sum. All right, for letter B, now that is a binomial squared, and we're going to learn the shortcut to that coming up. But for right now, when you're squaring something, what does that mean? To multiply it by itself. So what we are squaring here is 2x plus 4y. So we have to write this as 2x plus 4y times 2x plus 4y. We cannot just square each one individually. That doesn't work. That if it was multiplication, if it was 2x times 4y and then all squared, you can just square each one. But when there's two terms, a binomial, we're going to have to write it twice, and we'll figure out the shortcut in a little bit. And now we can FOIL this. 2x times 2x is 4x squared. 2x times 4y is positive 8xy. 4y times 2x is another positive 8xy. And 4y times 4y is positive 16y squared. So we're going to get three terms out of this, because this would be 4x squared plus 16xy and then plus 16y squared. And again, this would also be a degree of 2. Here's 2, this is 1 plus 1, which is 2, and that's 2 also. Alright, we're going to do 66 right here. One more together. Okay, so copy 66 down. Alright, so since it's a subtraction, the first thing we're going to need to do is distribute that negative sign through. So we have 5x to the fourth y squared plus 6x cubed y minus 7y, and I'm distributing that negative sign, so negative 3x to the fourth y squared plus 5x cubed y plus 6y minus dx. Again, we're just doing the opposite sign for everything that was in parentheses there. All right, as we go through this, we have 5x to the fourth y squared and then negative 3x to the fourth y squared. That will give us positive 2x to the fourth y squared. Then we have 6x cubed y, 5x cubed y. add those. Those are like terms. 11x cubed y. And then we have negative 7y and 6y, negative 1y. And then we have the minus 8x at the end. All right, now, what do you think the degree is for this one? So talk within your group. What do you think the degree is for this one? No, what do you think?
6.
It is 6, because if we add here, 4 plus 2 is 6. Here would be 3 plus 1, which is 4. Here's just 1, here's 1. So 6 is the highest sum of the term. So that would be a degree of 6. Alright, so you're going to take a moment in your groups, or when you're on, you're going to work on 72, 78, and 82 also.